Welcome to MongoDB Meetup SF. Thanks to Rackspace and Blake and everyone for giving us access to this space and feeding you guys. Tonight's talk is going to be by Kenny, as you will probably know. Blake's got a few quick things to say. One thing before, next month's talk is probably going to be from the guys at TokuDB, who do like a slightly alternative version of MongoDB that's semi-compatible. So I'll announce that after this meetup, but that's going to be a good one as well. So yeah, over to Blake.
Thanks everybody for coming. Thank you, Russell, for helping with all this and getting everything organized. I just want to say a quick word of where you are. This is a Rackspace office, but this is actually Geekdom by Rackspace. It's a curated co-working space for engineering-focused companies. So we have about 20 different startups that are working out of this space. Room for more. So if anybody's working on building a company and you guys are looking for some support around everything from marketing to cloud resources to mentorship, just find me. I'll be around. Happy to answer questions. Other than that, have fun, enjoy yourselves, and Kenny, I'll let you take it from here.
Thanks. Hello, my name is Kenny Gorman. I'm one of the 3 founders of ObjectRocket, and now almost a 1-year racker. I'm going to talk a little bit tonight about scaling MongoDB. I guess first of all, I'll give you a little kind of bio on myself, just kind of so you know who I am. I know a lot of you, but just kind of so everybody knows. And I just want to say humbled and happy to be here. A great group of people, great turnout. So thanks for coming. I know it's in the evening and things to do and traffic, and so thanks. Like I said, my name is Kenny Gorman. I have been doing database stuff for many years. Oracle, Postgres, MySQL, and most recently MongoDB. I was an early adopter of MongoDB, for better or worse, so I've lived through some pains. I've lived through some things that I want to share with you, some lessons, some interesting bits, some tricky things that I've had to deal with, both in before we started our company and now after we've started our company, which is based on MongoDB. So talk a little bit about that. All right, let's get into it. So I'll probably stand here if that's okay with everybody, just so I'm not in the way. I'm going to talk a little bit about philosophy of sort of scaling and sharding. I'm going to talk a little bit about the construction of MongoDB and how it works, its architecture. How many people here are using MongoDB today, like in production, like serious about it? Okay. And how many of you are sharding in your production? So not as many. Okay, got it. So I'm going to hopefully save you guys some pain. Maybe steer you in the right direction. I'm not going to give commands. I'm not going to be super specific about everything, although this will be highly technical. A lot of this is more of a high-level philosophical discussion, so that you guys have the tools you need to build, great systems and build a robust Mongo system. I'll talk a little bit about design, the best way to design MongoDB structures from a document level, from the architecture of a sharding layout. Talk about all those things so you kind of have a high-level design primer, and then I'm going to talk like what happens at scale. And so this is going to be where things fall down, what things you need to look out for, where there's maybe maturity gaps in MongoDB, some tools and techniques to kind of deal with those things. All right, so what is scalability? For purposes of this discussion, it is the ability of the system to horizontally scale. Okay, so I'm going to be talking about horizontal scalability. What that really means is MongoDB sharding. Okay, so I'm talking about sharding basically the whole time. So what are the benefits of scaling horizontally? Well, in today's world, it allows us to add storage and compute in a linear relationship to each other. What that really means is we're able to use small commodity nodes, maybe even with local disk, no fancy SAN setups, no Brocade switches, no fiber. None of this complicated and expensive infrastructure, or maybe cloud nodes, right? So just an abstract cloud node, you don't know really where it lives, you don't know how it's wired or what rack it's in, doesn't matter to you, you just want to be able to scale your system. So obviously there's many cloud providers and many ways to do that. And the technique is we're going to use many smaller systems to build our cluster. We're not going to buy big systems with tons of memory. They're expensive. So hopefully, if you do it right, there's a lot of cost benefits. I'm going to talk about how to do that. If you do it wrong, you're not going to get a cost benefit. You're going to get something that's very expensive and doesn't work for you and makes you want to cry. So the technique is to start small and grow over time. So this works for a lot of startups. You may not have a lot of cash to invest in giant clusters. So you can go out and you can buy a single node. You can design it properly and think about the sharding design. You can provision one of them, grow until you need another one, and another one, and another one. So it's a very incremental approach to building your business on MongoDB as the database and how to scale that with your workload as it grows over time. So just some high-level stuff there. So the question is, a lot of people say, do I need to shard, or do I need to scale my system, my MongoDB system? And it's a sort of a debated topic. Some people say you shouldn't shard until you have to because it's complicated, it's tricky, and you're going to fail, and it's going to be a mess. There's truth to that. On the other side of it is, if you start early thinking about scaling and thinking about sharding, when you go from one node to however many nodes, you're going to be ahead of the game, and your mind's going to be about scalability in Mongo. You're going to be thinking about shard keys. You're going to be thinking about designing for scalability. So if you do it from the get-go, you'll be in a better place. Plus, most of us want to succeed. Most of us want to build big systems, big databases, because that means our businesses or our startups are thriving. So when you say, do I need to scale? I think the answer is yes, in my opinion. So scaling vertically works for a while. You can take a single node, and you can grow its memory footprint. You can move to an XL double large or whatever it is. You can add more memory if you've got your own hosts. You can do a variety of things to scale vertically, but it only works for so long. And part of the reason of that is the ratio of memory to disk changes over time, right? So if you have 5 gigs of data, that fits in your memory, in most systems, most modern systems. The worry about whether or not you're going to miss memory and go to disk is very small. As that system grows, that ratio will change, and your performance will change. So it's very hard to have predictable scalability in that model. So that's why starting small, sharding from day one, and growing that over time is a much easier way to do this. So before you do anything with sharding, I just want to be clear about one thing. The first thing you need to do is split your workload. So what does that mean? If you have, I'll use a whole bunch of examples like a Twitter clone. Okay, if you're building a company that's a Twitter clone, you're going to have tweets and say users, for instance, collections or tables in relational speak. You're going to want to split these workloads. You're going to call each one of these a different workload. You've got a tweet workload, you've got a user workload, you've got maybe some other workloads. You're going to want to split those first. And then you're going to want to scale those workloads horizontally. There's a couple of reasons for this. Number one is, once you split in a smaller chunk, it's easier to manage, it's easier to think about, it's easier to design for, and then ultimately it's easier to scale. I'm going to talk about some tips and techniques about how to do that.
What do you mean by splitting?
So, good question. The question is, what do you mean by splitting? What I mean is logically take that collection of data and have it on a separate MongoDB instance. Okay, so you've got instance A with its connect string, like whatever, localhost 4,000. That's users. Localhost 5,000, that's tweets. Okay, so separate databases. And in your application, you're going to logically join those where needed. Okay? So think about being able to do that in your application day one. So I talked a little bit about splitting vertically versus horizontally. So the design for MongoDB's horizontal scalability is what they call sharding. And I'll talk a little bit more about what the architecture looks like. And then the other component of it is the keys, the shard keys, and the collections. So a collection in MongoDB, if you're not familiar, is like a table in a relational database. The key is the key that you're going to split data on. And then the architecture is the overall architecture of how instances get glued together to participate in a cluster. I have a picture in a second, I'll show you. You really need to think about achieving your scaling goal. So what is a scaling goal? Well, in this Twitter clone idea, or example, you may want to tune your tweets for writes, right? Like you want to just take writes. You never want to miss a write. That's the workload you care about. But maybe users isn't like that. Maybe users is more of a read-only type thing. Maybe there's more reporting queries, things like that. So this is why you may want to split. Keep the users cluster separate. It has a different workload profile. Keep tweets separate. That has its own workload profile. And maybe on the writes you have 20 shards, and maybe on the users you have 2. Okay, so you can have an asymmetric design to match the workloads of those various collections. As well as lock scopes. So how many here know about Mongo locking? Heard about locking, Mongo locking? Yeah, okay. So Mongo, it has a controversial locking model. It is based on yielding. It is not like a relational database in any way, shape, or form. It is locky in nature. So locks are something we care very much about in MongoDB and something you want to try and tune for. With sharding, in regards to sharding, having more shards gives you more lock scopes, so it gives you another dimension in which to scale your system. And sometimes you may scale just because you want more lock scopes. Okay? And I'll talk more about that stuff in a bit. So I know this is high-level stuff. We'll get more technical in a minute. So this is just like the most basic drawing I could create for sharding architecture. And I did that on purpose. I don't want to talk about all the little bits and the daemons and the config parameters. I just want to give you an overview of what sharding looks like on MongoDB. So at the top, you've got a client layer. That's your application. Then you have a middle routing layer. So that takes connections from your application and routes them to the shards that have the data. So how does it know what shards have what data? The metadata repository, or the config servers, hold that information. And I'm going to show kind of what that data structure looks like and how that works in a second. I'm going to talk about some limitations there too. And in this picture I drew like a 3-member replica set, just because that's how we typically configure it for the databases. So your data lives down here at the bottom. That's where your actual customer data is. The routing layer is just a layer that just routes incoming connections. When you ask for ID 12, it'll go to one. When you ask for ID 13, it'll go to another one. So, shard keys. There's a couple different design patterns for shard keys in MongoDB 2.4. There's 2 methods, and before that there's only one. The range key was the initial design. Range-based keys are a little bit more difficult to deal with. The way that works is imagine, say, a user ID field. Maybe it's a long. And you have to split it up into ranges. So you'd say from like -1 billion to like 0 is one range, and from 1 to whatever, that's another range. And that'd be 2 shards in that design. You have to know your workload. You have to know your keys, right? So if you're using keys that increase over time, you could skew your workload. You could skew your balance. So it takes a little bit more tricky and some more thinking involved with range-based hashing or range-based partitioning than hash-based partitioning. So hash-based partitioning is where it's like an MD5 sum of the value and guarantees perfect leveling between the different shards, right? Perfect balance, or near perfect. So it's a more generic and easy option, but it may not fit your performance profile. So if you really know what you want and you really know how you want to scale and how you want to shard, it may be too generic for your needs. So maybe you start with that, and with something maybe you don't know what the keys are going to need to be, you hash shard that collection, maybe another collection like, say, tweets. For sure I want that to be user ID because I want to optimize for that. So I'm going to choose that range base. So they don't have to be the same in different clusters. So how do you know what a good shard key is? How do you figure that out? Well, partially you just have to kind of know your application. You have to know how you fetch things. But you can use the profiler in MongoDB. If you don't know about the profiler in MongoDB and you're using Mongo, you should know about it. It is a fantastic tool and one of the coolest bits of MongoDB, in my opinion. You should turn it on, and you should leave it on. It's sort of a controversial statement, but it is a performance impacting event. But I say it's not much, and when you know more about your system by gathering this data, you can make more intelligent choices, so it's worthwhile. It's a worthwhile trade-off.
Don't you just need to make those choices once, optimize your database, and then you can turn it off?
Yes, it's true. So I say leave it on because there's a lot of other benefits. But for sharding, you're right. You need to turn it on, understand what workload is happening, make a decision. Because once it's a non-changing component, right? So once you define a shard key, that's what the shard key is going to be, unless you actually delete the collection and rebuild it. So correct. And explain. So explain is Mongo's way of understanding that query plan. It will show you what shard key it's using, what index it's using, so you'll know exactly what shards it's visiting to get the data. And so there's local queries and there's scatter gather. A local query, as it sounds, is a query that is directed to one shard. So if user ID equals 10 and the data is on shard number 1, that's a local query. It'll go right to that. A scatter gather is if user ID is like range between 1 and 1 million, it's probably got to visit all shards. Or imagine if you don't even specify a predicate. It's got to visit all shards for a given query, pull back the data, sort it, and return it to you. And I'm going to talk a little bit about the trade-offs between those two things. And I think the key takeaway here is that you may not get every query to be local. That's kind of what you want. But in a big system, if you have a small system and it's got 5 queries, 5 different queries you're running, it's pretty easy to make them all local, likely. But if you've got a big system and you're scaling, it's very difficult to make all those local. So, if you listen to the training materials or documentation, it makes it sound very black or white. Choose a good shard key, and it's like, or you missed, or you didn't, and you failed. Well, it's not really like that because you've got 1,000 queries. So it's like just trying to aim for the most queries you can to be local and let some be scatter gather, and that's just the way it's got to be. I'll talk about that. So the key is to plan ahead. Plan ahead with your shard key design. Plan ahead with your decision about scatter gather versus local, and plan ahead about what type of keys you're going to choose. So this diagram kind of indicates, gives you a feeling for like kind of my thinking around targeted versus scatter gather. It's really just an odds game. You're really just trying to say, hey, 20% of these things are scatter gather. 80% of them are targeted local queries. Hey, that's fine. Maybe the local query is your primary workload, like the tweet workload that I was talking about. And maybe like the scatter gather is your reporting workload, like the business user comes in and needs a query, different queries, and is going to hit all the shards. Maybe that's okay. You don't really need to tune for that. It's a business user. He can wait. All right, so let's just talk a little bit about how you shard. So it's a collection-based operator, okay? So you shard a collection. You take a collection and you define a key on it, and that's how the data gets split. So like I said, you can have a tweets collection and a users collection. They each need their own shard key. Again, they are range or hash-based. When you shard a collection, it's going to break up the collection into what's called a chunk. And a chunk is a 64 megabyte piece of data. So it's 64 megabyte chunk of documents. And that is the unit that gets moved from shard to shard. Okay? So the balancer picks up that chunk and moves it from shard to shard to keep everything level. I'm going to talk a little bit about the balancer, what it is, how it works, and how it fails in a minute. In fact, it's kind of a rant. And like I said, chunk location is determined manually. You can always move a chunk wherever you want it. You can say, I want this chunk, number 5,000, on host B, and you can do whatever you want there. The balancer will try and keep things level for you. So the balancer is going to look at the storage space of those clusters, or the number of chunks in those clusters, and try and make them equal. Now, they're not always equal, right? Because you could have different workload that hits a different chunk than another. But the algorithm for the balancer is based on the number of chunks, or the chunk count. And so this is a basic shard key definition. It's in the config server, the metadata server. You've got a key on ID that's hashed. It's got a couple other bits of metadata. This is on the users collection, and it's not a unique key. Just a little sample of what the JSON looks like. All right, so this is what chunks look like. I just do this as a kind of representation of to give you a feeling for what chunks look like. So you have 64 megabyte chunks on. So you've got, let's just start here at the top. You've got shards, 2 different shards, same database, same collection. Okay. It's split into 64 megabyte chunks, and the balancer tries to keep them even. It tries to. They're not always even. If you have an odd number, it can't do that. So that's the basic design of chunks and how the balancer interacts with them. This is what chunks look like in the config server. If you've ever poked around in the config server, check it out. You can just say use config on a sharded collection. Don't change it because you'll ruin everything. It is the metadata key to your cluster. It is something that you should back up. It's something you should care about. Don't change it. It'll ruin everything.
You have 2 copies.
Yeah,
You have 2 more copies.
you do. In most cases, you have 3, right? If they differ, your cluster stops, by the way. If one of them's down, things can't move, by the way. So there's some tricky things there we can talk about further along. Anyway, this is what the metadata looks like. The namespace is the user's collection. In this case, there's a min and a max. So that's the range I talked about, the range-based partitioning. In this case, it's a last mod when it was moved. and what shard it lives on. So that's just a string for what the shard name that it lives on. Okay. So takeaways from shard key definitions are that a proper shard key is critical. Every person you talk to about sharding will tell you that. It's a pain in the ass to change it once you've defined it. You have to do things like export your data and re-import it with a new key. It's a nightmare. And as you grow, it's going to get harder and harder. So that's like a key takeaway there is, so let's say you have a dev, like, so you guys develop in production or? Okay, right. So it's like, get a dev system, get a test system, build in those systems the shard keys, test them out, look at the profiler, see how they look, make sure they're targeted or local or whatever they need to look like, and then graduate that into production, right? And the good news there is you're testing out with something that's fairly small, so in your dev data set, if there's problems, if it blows up, if the queries are horrible, there's some recourse before you go production with that. Once you go production, well, you're not in too bad a shape until, down the road you've got 3 terabytes of data, and how do you change it then? That's tough. Explain that to your boss or whatever. All right. It is a tricky thing because so in documentation and in most talks about sharding, they make it sound like it's a one-time decision. Once you've made it, you're set, and it's black or white. It's not. It's not. It's a compromise. It's always a compromise, like I showed the pie chart. Number one is. And number two is it may change over time. So your tweet application may evolve, and you may have new queries that are different from when you first designed it. Your shard keys can't change. So there's some interesting things to think about there. It's how do you combat that? I think the answer there is you need to think ahead about where you may want to take your application. Also, you may choose, in some cases, to choose a hashed ID key because you don't know. So you're choosing something that may not be as fast as it could be, but it's more generic and maybe a little bit more safe, okay? Again, use a profiler, like I said. That's the coolest part of Mongo, profiler, I love it, obviously. And the explain plan, or I say explain plan because that's old school Oracle stuff. But explain those queries. Last but not least, understanding the balancer's effect on your workload. So the balancer's going to run. How does it run? It goes and it fetches those chunks. It reads them, okay, so it's doing logical or maybe physical I/O. It's taking them, it's moving them to another shard, so it's writing them, and then it's deleting them. So it's a ton of work. It's a ton of I/O. It's a ton of disruption. That I/O is taken away from your customer workload. So someone has to pay the piper. It's your customers. It's someone who has to wait because the balancer's running. There's no free lunch there. So, if there's a couple takeaways, I'm going to talk a lot about I/O here in a minute. You probably don't have enough I/O on your system. It's like you probably don't have enough iron in your diet or you're dehydrated or whatever. You probably do not have enough I/O on your system right now. If you're running in the cloud, maybe you don't even know what kind of I/O you have behind your system. That's a danger. That's a red flag. So if you can pick provisioned IOPS and you can run bare metal and there's, all the providers have different solutions. Do a little research and understand what those I/O subsystems can do and what they look like, because it's going to matter, especially when you decide to balance.
Excuse me. For the balancer, do you have an option to turn it in like a power level of something?
You do. I'm going to talk about all sorts of tricks to make that less. I want to tee it up and scare the shit out of you, and then I'm going to give you some fixes. So, all right. So that's kind of the deal. Okay. So you don't have enough I/O. I know that for sure.
I missed maybe what's the best practices IOPS? Like I know on quickly read stuff on SSD, it's 5-10 microseconds local. Other systems are from 1 to 10 milliseconds.
Yep. So the question is what's the best practice? I'm going to talk a little bit more in a little bit about that. But sure. More I/O is better. That's easy because it's always a cost-benefit analysis. Sometimes it's just too expensive. MongoDB does love very low latency fast storage. Okay. It does love SSDs. I'll tell you that right now. I'll talk more in a minute about that. There's some other tricky things about the balancer. Visibility is hard. So you'll be out to dinner some Thursday night, you'll be eating your dinner, and all of a sudden your world will end, and your pager will go on, or your phone will go off, and you'll look at the monitor and you'll be like, our whole system is totally screwed. What happened? Well, you will know that the balancer woke up and decided to balance a whole bunch of chunks while you're at dinner, and all your users got huge latency. So planning ahead for the balancer, knowing that it's running, knowing its impact, planning ahead for that. I'm going to talk about some strategies there. And just the process of balancing itself. I talked a little bit about how it's got to read the data, move the data, write the data, delete the data, and there's some other tricky things where it may not get that delete done, and it may leave something called an orphan. I'm going to talk a little bit about what that is and what that means to you. So this is a simple little function that talks about how to, or shows how to see the balance of your system. You can just hit the GitHub there for that. This kind of query is really important because you're going to want to see how many chunks live everywhere and how balanced you are. If the balancer stops working, you may not know that you're out of balance. You may not know that shard number 1 is 100% pegged and shard 2 through 50 are doing nothing. So we're going to talk about monitoring too, and that's a big component to that. But this is how you look at the cluster and see if it's balanced. And this is the output. All right, so this is the output. In this case, we have shard ending in C88. It's got 1 chunk. The next shard is C41. It's got 77, and B59, it's got 77. So three shards in that cluster. 2 of them have even chunks. 1 of them's only got 1 chunk. That's bad news.
Shows you that, right?
What's that?
Status on MongoOS shows you that too.
It does. It does. This is just a compressed way of seeing it. It shows it nice and neat. But you're right. sh.status is the command that will show it. All right. So this is a graph of that Thursday night, basically. Real story here. So we call it balancer havoc. Basically, this is the inverse of what you might imagine. So you have response time here in milliseconds, and you have like time series across the bottom. And each one of these different colors, because I know you can't see it, is a component of a system. One of them's like API, one of them's app, whatever. And this system's running, and then all of a sudden, everything gets better. Response time is like fantastic. So what happened there? Well, the balancer shut off. It got finished balancing. So your system may be different. Your system may all of a sudden be running with that low level of latency and then go through the roof. It gives you a feeling for the scale, right? It's a big deal. So that's why I showed this.
Higher numbers are worse?
In this case, yeah, it's response time from the application component. So the application in this case was measuring its response time in milliseconds to the database. It was seeing, a second, or probably on average, half a second-ish. And all of a sudden you're down at like the 10 millisecond or 20 millisecond range, okay?
Is this one of the tools that came with it? Or?
No, this is Graphite.
Okay.
I have some scripts. I'll show you how to get this information into Graphite in a sec. So how do you fix the balancer? Big scary balancer. So a couple things. You can pre-split. So you don't have to run the balancer. You can leave it off. You can turn it on and off. If you know the sharding pattern of your application, you can go ahead and pre-split it. So let's say you have a huge import you want to do. You could split those chunks and move them empty to wherever you want them, import the data, and then it's static. It can just stay there. It doesn't have to move. So that's one technique. You can use Windows, and I don't mean like Microsoft Windows. I mean balancer Windows. Don't use Microsoft Windows with Mongo. That's another tip. So balancer windows are just a time frame, a time window that the balancer can run. And this is actually the most effective, frankly, the most effective way of protecting your system against balancer havoc. So the way you use it is you simply just turn it on for, say, the weekend. You know that people aren't tweeting a lot on the weekend. When the Super Bowl comes, you leave it off. You don't balance during the Super Bowl, right? So there's some common sense things you can do there. Micro windows is a technique we've used where we use code and we just turn the balancer on and off, like every 5 minutes. And this is basically throttling the balancer, right? Maybe it's not every 5 minutes, but you get the point. On and off, on and off, on and off over like a day period. And then maybe like on weekends you don't, kind of thing. So custom plan based on your own code. Secondary throttle is a setting that was optional in 2.2, but now default in 2.4, which means that the balancer will throttle itself by waiting for it to get written to a secondary. So it goes and waits for something to be written to the secondary before it goes and does a delete, therefore kind of throttling it. This is a tricky setting because if it doesn't get that delete, you have an orphan. And I'm going to talk a little bit about orphans. Or just don't use a balancer. Maybe you don't need it. Think about it. I mean, maybe you're using hash-based partitioning, and maybe your data set isn't growing terribly, and you've pre-allocated 200 shards, and there's 5 megs on each shard. You may have a lot of headroom. You don't need a balancer for years, maybe.
Are you going to cover how the balancer chooses a shard, or is that not in this?
It is, I can talk a little bit about that. The question is, how does the balancer choose a shard?
Sorry, not a shard, a chunk.
The balancer chooses a chunk. So
I've not read the code.
yeah, so we can talk a little bit about. Let's talk about that afterwards. Yeah, because I think there's a lot there. So let's talk a little about what happens at scale. I think we talked about the balancer and its impact. Let's talk about fragmentation now. So I said that the balancer runs, it's pulling data and moving it around. Part of that's a delete. And when a delete happens in MongoDB, yes, that space is reusable. It frees up that space and something else can use it. If it's not the right size, it's going to have to actually get moved. And that may leave a hole in your data. In fact, it will. So your databases will fragment when you're running the balancer. It's most likely. Because deletes happen, hopefully. So fragmentation is mostly guaranteed when you're sharding. That's a big deal because as you fragment, you're essentially wasting storage and your systems are growing. So you may see a growth profile that seems to be like radical compared to what you had before. Now that you're sharding, it's growing much quicker. Well, that may be due to fragmentation. So therefore, your life is about compaction. And you have to do it without interruption, right? So one way to compact is like, run repair. That might take hours. If that's okay with your system to be down for hours, then easy. That's an easy fix. Most people can't do that. There's a compact command. However, that, again, is an impacting command. So what do you do? Couple things. Number one is set power of 2 sizes. There's no reason not to set it on every damn collection across every database. It is a little wasteful at the beginning, perhaps, in terms of its space allocation, but overall, in terms of fragmentation, it's probably a win. So we set power of 2 almost uniformly across everything. It doesn't always work, but why not? The next is a technique called the shell game, which is how you actually compact. So what we do is we use replica set. I showed you a 3-member replica set. You fix Mongo by deleting one of the members. I know this is counterintuitive. But so you've got 3 members, you delete one of them, and it rebuilds, right? So it's going to go ahead and go out there, rebuild all the data, rebuild the indexes. It's now compact. And actually measure the difference, because you'll see a measure of your compaction between the two. Sometimes you maybe need 4 members or 5 to have the level of availability you need. A member will vote, by the way, once it's got past startup 2 and it's in recovering, it will start to vote. It'll be a voting member. So it doesn't have to wait for the entire rebuild to finish to be a voting member. So that's important, I think. And then once you've done all your slaves, you just do a step down. So you do an election on the replica set, and now you get that compact member as your primary, and you can go ahead and rebuild the one that was previously a primary. That's a lot of work. Maybe you don't care if you're fragmented. Maybe you don't care about the disk space usage. You probably will. Disk is expensive. So this is one way to deal with it. One of the things we've done in ObjectRocket is we automate that. So that's actually a command on our system, and you can actually tell it over time and when you want it to happen and other things. And it's all based on this stuff. Like I said, our service is sharded predominantly, and so we have, at this point, thousands of instances that are running, all fragmenting all at once, and so we needed some way to cope with that sort of huge amount of demand and huge amount of fragmentation. So tip there is don't let your shards get out of balance, or compaction will be needed. We call it compaction. It's really just deleting a member of your replica set. Okay, let's talk about orphans. I mentioned orphans. So what is an orphan? An orphan is a document that exists in a place that the metadata or config server does not know about it. So how does that happen? So let's say you have a user ID, a tweet with an ID of 100, and it gets moved, right, via the balancer. That chunk that it's in gets moved. And then the delete fails for whatever reason. And there's a variety of reasons that can happen. It doesn't roll back or do anything. It just finishes up, but leaves this guy behind and updates the config server to know the new place. But you still have data over here. So if it happens a lot, you're wasting a lot of space. And certain commands will not adhere to the filter. So a count may come out wrong. So if you counted those tweets, it would count both. That's a limitation of the count command. There's other unique scenarios that will give you actually wrong data. So orphans are bad. You do not want orphans in your system. Disk space reasons, consistency reasons, etc. I say have fun with that because it's a pain in the butt. There's various bugs around it, counts. Orphans need to be removed. So how do you remove an orphan? So 2.6 will have a command that cleans up orphans. You'll just be able to run it, and it'll go out and make the decision. Today, there's a script called orphanage.js. It's built by the support folks at MongoDB Inc. And if you just Google for it, you can download that, and that will help you clean up. So keep that in the back of your head. And so go vote for 2.6. Go help with getting 2.6 out by looking for bugs and helping with the 2.6 effort, because 2.6 is a big part of that fix.
If you have two orphans, they probably have the same ID.
Yep.
How do you determine which one, if you have two records, how do you determine which one needs to be killed?
It's not in the confidence.
Right. So the question was, if you got two copies, how do you know which one's valid? Is that fair to say?
Yeah.
So the config server knows. So remember I talked about the routers? Comes in and says, hey, I need ID 100.
Right.
It knows there's a cached copy of what's in the config server in every Mongo router. It's going to come in and say, oh, you live on shard 10. And it's going to go to shard 10. So that's the one that wins. Every shard, by the way, may have a copy of it. They move the balancer runs all the time. Right? So it could be moving and orphaning everywhere. So it's definitely a big concern. So that's, anyway, to answer your question, that's how it knows. The config server tells it. That's where you go for your shard. That's the valid one. The way you clean up is you say, tell me where ID 10 lives other than where the config server says. So you have to scan every database and say, oh, I found one. Okay, that's invalid. Oh, I found one. That's invalid. Oh, I found one. That's okay? So key to a lot of this is monitoring. Monitor everything. But let me give you some key things to monitor for when you're sharding. Obviously, the shard size. And by size, I mean chunks, and I mean disk space, and I mean ops. We'll talk a little bit about ops in a sec. They're not guaranteed to be equal, right? So the balancer is balancing on chunk count. It's not balancing on the number of Mongo ops you're doing, or even the storage footprint, because it's not guaranteed to be the same. So your shards may be asymmetric a little bit, maybe a lot, depends on how much fragmentation and orphans you have. So monitor that. That'll give you a feeling maybe for what needs to be compacted, what may have orphans, or maybe just like a bad design on your shard key. So it's a whole bunch of things that will eliminate. Check for the balancer on and off. If you're running the balancer and that's how you run and you depend on that, monitor it, because when it's off, you're in a deprecated state. Seems obvious, but it can fail in strange ways, and you will not know that it's failed, and then you'll have a lot of catch-up to do, right? And you may not be able to fit in your window anymore. You may not have enough I/O to do it. So kind of plan ahead there and monitor for the balancer on/off. Also, monitor response time. So I showed that graph of the terrible response time. Monitor that, right? So if something starts to get off in your cluster, you may not know about it until you know about the response time you're giving back to the customer. I mean, by customer, I mean the client or the application that's consuming the data. And the way you can do that is in the profiler. Interesting way to do that is in the profiler. You can actually summate or average or max or min or whatever function you want to run on the millis attribute of every document. So if you say summate all those, you'll know the sum of response time from all your queries. Another reason to leave the profiler on. Monitor for failed migrations of chunks. So we talked about that may be orphan inducing. The way you do that is you need to look in your logs. It will tell you, the balancer will tell you if it can't complete. So 6 stages to the balancer, just to get a little bit deeper. If it fails that last stage, that cleanup stage, it will alert you in the log. You'll want to know about that.
Is there a code? Error code?
There is. I don't remember it. But it tells you, if you look in the logs, it'll tell you phase 1, phase 2, phase 3, 4, 5, 6. Monitor locks. So I talked about those lock scopes. I talked about designing for scale. You're going to want to know if you need a new shard based on locks. So the question comes up, how do I know I need to grow my cluster? Well, we're monitoring for shard size. Obviously, if there's disk space problems, you're going to want to add, right, and get the balancer to run and even those out. By the way, don't wait until it's too late, right? Either you're out of IOPS or you're out of space. It's too late. Or maybe it's just like, you're monitoring your locks and your lock scopes are really high and your queue times are high. You may say, I need another lock scope. I'm going to add another shard. Don't wait until it's too high because it takes lock scopes to balance. So you're going to be using the very thing you're trying to save. So you got to plan ahead there too. Some folks actually will shard when they feel like it's 50%, like half the capacity of their cluster of any one shard is at 50%, they'll add a shard. Okay, so that's like super planning ahead. But you do that because you need that I/O, you need the things you're trying to fix to get the balancer, to get the data over to the thing that you're adding. And do histograms, like I showed the graphite thing. This stuff changes over time. It's a time series problem. It's not something that happens once and then goes away. You need to monitor it over time. You need to see how it behaves on a Sunday. You need to see how it behaves throughout the life cycle of your app, whether that be like a promotion or you got featured in the App Store or whatever those things are. You're going to want to be able to know over time how that affects your cluster. So maybe what you say is like, every time we do this one promotion, our locks go to the roof, our I/O goes to the roof, and therefore I need to add a shard to give me the capacity I need just for that time frame. You can also remove shards, by the way. It's tricky stuff too, but there's commands to do that. So if you want to scale up and scale down, you can do that too.
Excuse me.
Yeah.
So the shard size is also accounted by the orphans, and so if orphans are still around, there might not be something very legitimate to look about to add.
Yeah.
new shard.
So I think if I can summarize the question, basically saying if orphans exist, that shard size could be bigger because of those. Yes, that's true. And the balancer will not know about that because it reads the number of chunks from the config server. So it's a blind to those orphans. So that's why I say monitor the disk size, because you may want to have one shard that's just got a ton of space consumed, and you're like, why is that? It's not balanced. You look at chunks. The chunks are balanced. What's going on here? How can that be? Look at fragmentation. Look at orphans. It's an indicator, a clear indicator that these things may exist, and you need to go clean them or take some action. Good question. All right, capacity. So a big part of, I was just talking about this, a big part of failure in these large systems and large sharded systems is about capacity planning, frankly. And I know it's not the most glamorous thing, right? We all like to write sweet code. We like to get featured in the App Store. We like to have the newest, Node app, whatever. But this stuff is critical. Capacity planning really matters to not only the performance of your system, but the system outright stopping. So at the bottom here, we talk about, I don't know if you guys remember the Foursquare outage, Mongo, huge thing. So in my opinion, I think,
HQ?
what's that?
Is that Mongo HQ?
No, this is 2010. Foursquare uses MongoDB, had an outage, and it was a very public outage. And that's the link to the blog about it. And if I can summate the problem there, it is that they forgot to plan. And they waited until it was too late to add either I/O or add indexes or add the things they needed to get the compute they needed, and they're out of those very things, right? So they didn't have enough disk space to move the things off, because balancing takes disk space, to move the chunks off the thing to get that particular shard to be performant again. And therefore, they just had to take everything down, focus on balancing. System's off, I'm balancing, right? That's not appropriate. That's not good. And someone gets fired, it's really bad. Customer, we're done balancing. Customer doesn't want to know you're balancing your cluster, right? So this is the lesson, in my humble opinion, about of what this taught us as a community, I suppose. So don't fail to plan. Disk space and size is critical. So there's a couple hacks. There's a couple things you can do. Set max size. So max size is a long in the config server. I said never change it, but it's in the config server. I said never change it, but maybe you want to change this one thing. Back it up before you do it. So max size is a long that represents the amount of disk space that the balancer is thinking that this host has. So you can kind of game the system. If you've got, let's just say, for sake of argument, 4 1 terabyte shards, and let's say one of those is particularly hot, you can tell MongoDB not to favor that hot one by setting max size to some artificially low value. And it will just say, okay, you get a chunk, you get a chunk, you get a chunk. Oh, don't have room here, and skip it. You get a chunk, you get a, and it will be okay with an asymmetric design because you've told it to do that. So that's something, a dirty hack you can do to sort of initiate or force an asymmetric design in your cluster. And the balancer does it online. It's an online thing. It takes literally nothing. You can set it down, set it up, move it around. So it's a pretty useful tool. If you're using like an LVM or something, you can extend your disk space. Maybe you're on a SAN or something that's super easy. I can add a terabyte to one of these shards. Who cares? That's fine. You can do that. I've done that myself. I've been woken up and, I have to do this right now because I'm out of space. And And so you do it, you LV extend or whatever. The problem there is now you've got this sort of asymmetric design to your shards, and it's hard to clean up later. And frankly, you never go back and do that, right? Like, we're all a bit too busy. And so you end up with these weird sharding patterns, and things are bigger, things are smaller, this one's more fragmented than that one, and it makes a mess. So my suggestion is do that sparingly. You can add CPU or memory to your cluster. So one technique I talked about, that shell game, let's say you realize, oh crap, I'm going to need, way more memory on every one of these systems. I just screwed it up. I got too little, and I don't know what to do here. What you can do is you go into each one of those slaves on your system. You upgrade those, right? So instead of deleting it, like I talked about compaction, you just take it out, you put the new hardware in or whatever you need to do, you put it back in, you let it resync, and then you step down until that one's live. And so that you can kind of do a rolling upgrade that way. Now you have to visit every shard of your system. So if you have 100 shards, you got to go through every one of those. But it is an election, a MongoDB replica set election, and not some other horrible impacting event. So it's a fairly, if your app is tolerant of elections, which it should be, then it's not a huge deal for your application, for your system. So that's the shell game. So no matter what anybody says, you need I/O. If you're working on a system and you don't know how much I/O you have, or you're seeing crazy balancer patterns, look at your I/O system first. So use your I/O stat, look at await times. This is going to tell you if you are out of I/O. And do it during a balancer window so you know what the balancer is giving to your system or injecting into your system.
How many times you've seen a need for expanding the CPU power compared to memory or I/O?
Yeah, good question. How many times have you, the question is, how many times have you had to expand the CPU processing power versus other things?
Memory.
Yeah, Mongo doesn't use the CPUs very well. It uses just a single thread, so almost never. Where it does use it is when you build indexes. So I talked about when you delete one of the slaves to compact it, you actually wait a lot on that index build because of the processor power. So do you get a fast processor just for index build times, or do you, that's a decision you'll have to make, but that's kind of the trade-off.
Okay, thank you.
But memory, yeah, memory is a big deal. Anytime you're doing something in memory, you're not doing it on disk, cool, but don't be fooled into thinking that just because I have a lot of memory, I don't need a lot of disk I/O. Because what will happen is that Thursday when you're out to dinner, you're going to do a miss or maybe a lot of misses because of some pattern, because of some promotion, maybe your customer pattern changed. You're going to go to disk, and instead of being like a little bit slower, you're going to fall through the floor. And if that coincides with a balancer window or some other thing, you're done. You might even be down. So something to think about there. We talked about a lot of these things already. Out of disk space or other resources, do not wait. Do it ahead of time. Keep track of your cluster as it's growing so you know what it needs. It's just care and feeding, right? You're just giving it more resources. You're doing your capacity planning, and you're adding it where you need it because you're using tools like you're checking to see how balanced your shards are, you're using I/O stat, things like this. Check out balancer havoc, so know when your balancer runs, know its impact on your system. And it's honestly, it's to the point where we'll get a call, and somebody will say, oh my gosh, the response time just fell through the floor. And the first thing we say is the balancer on? Yeah, turn it off. Okay, we're cool. So it's literally like, 9 times out, it's sort of like, the old thing with query tuning, where it's like, hey, I just did a push to production, and my app's really slow. It's like, yeah, did you miss indexes? Because you just pushed it. Oh, you did? Yeah, okay, you're cool now? Okay. So it's a similar pattern to that. Be sure that there's a gotcha is that you have no I/O left. Like I said, when the balancer runs, if you do not have that excess I/O, it's going to take it from somewhere. It's going to be a response time of your customer or your application. So make sure you have adequate headroom for even the balancer cycle. Be careful of shard asymmetry. It is more just a bookkeeping thing. It's an overall holistic performance thing. If shard 1 is really heavily used and it's out of balance, then you're only getting the maximum. You may have 100 members in your cluster. You're only getting the performance of shard 1. That's a shame. So you're not really getting a great ROI in your cluster. So try and keep things balanced. Try and keep the chunk counts even though that's not going to guarantee you equal performance. It's the best you can do with the tools that you have inside MongoDB and the design of Mongo. Avoid scatter gatherers where you can, but it is a compromise. It is something where you can't. You're not always. Just don't feel bad about yourself. Don't get dejected. Just say there's going to be scatter gatherers when the reporting guys run their query, that's a scatter gather, they're going to have to wait. It's going to be slow. So just be okay with that. Just be like, okay, that's fine. That's the design. And think about fragmentation. Fragmentation is a big deal. I think Tengen's aware of that. They're working on fragmentation fixes. 2.6 is power of 2 helps. 2.6 is I think there's some fixes, and then I think on the roadmap there that's one of the huge things that's being worked on. So do these things. Don't wait. Like I said, detect and manage orphans. Orphans, if they make your data counts show incorrectly, if you're using counts in your application of MongoDB, your counts may come out wrong, and that's a big deal, in my opinion. There's a number of issues and bugs out there around this, and I think that's something as a community we should we should pressure Tengen on, frankly, or MongoDB Inc., because we don't want our data to come out wrong, even if there's orphans. It should respect that filter, my opinion. Keep current, keep as current as you can, right? Like, so stay current -1 or some level of safety. Don't go loading the very, very latest MongoDB binaries. Let someone else find those issues. That's just how it goes, right? I mean, we all know that it's a known thing. But keep as current as you can. Like I said, 2.4 has power of 2. 2.4 has hash shard keys. There's more options. And so when it's safe to do so, upgrade and use those things. Those are out there for a reason. Use max size. It's a cool tool or a cool way to give yourself a little wiggle room. Maybe make this asymmetric design of your sharding or your clusters like out of whack a little. You can set max size to kind of goose it in different directions. Maybe you actually move chunk yourself, like you just start managing chunks. One of the things we typically do is we will have to move shards around. So we'll have to take this one out and put this one in and move this one over here. And so we're actually actively draining and loading shards. So we have scripts that basically go out and iterate through all the chunks and move them from point A to point B or vice versa. Just one tip there, always do some amount of sleep between move chunk commands. I don't know what the value is yet. We're still working on that, but like a couple seconds. It'll be slower than you want, but you must throttle it. Otherwise, you will just break your database. It's just too much. Too many move chunks at once will cause a database to come down. Explain and profile your queries. That goes without saying. We talked a lot about that. Every one of those queries that you explain tells what shards it's in, tells what shards it's hitting to get its data. So it's like the perfect way to understand your design pattern and your shard key pattern. And then the I/O, we talked about that a whole bunch. So just a note, if you want to do this for a living, I just laid this out and now you're all scared. If you want to do this full time, come work with us because we deal with sharding and these things a lot. I told you we're a sharded system. It's pretty fun. Learning all these things and overcoming the challenges and figuring out cool ways to keep systems up when presented with challenges, and that's what we all love. So anyway, hit me up if you want to work with us. Questions?
Yeah. So when the shell game, people should be aware that causes load obviously on that shard. So
yep.
That should be obvious though, hopefully.
So the shell game I talked about, when you delete a member and you let it rebuild, it's rebuilding from somewhere, and generally the primary. If it's not rebuilding from the primary, which is possible in MongoDB, you actually expose yourself to a couple other bugs. So do it from the primary is my suggestion. There's commands to force that to happen. When you rs reconfig, you can force that. So do that, and then when you do it, be cognizant of the fact that it is pulling blocks. Now, it doesn't do it through the cache, right? It goes and grabs those blocks right out of MongoDB, right from the storage layer. It doesn't go it doesn't run a query. So your cache, your memory map file profile is not changing. So that's cool. So it's not affecting your caching algorithm, but it is adding I/O to the system. It does have to do a read. And go ahead.
You should generally also test this before you do it. Like, how long is this going to take to read this much data?
It's good advice.
If you don't, then who knows? It might be running for quite a while.
And if you and interesting, so just if you didn't hear it, what Russell said was you should test it so you know how long it takes to rebuild a slave. That's fantastic advice. And another thing is, if it takes a really long time, you may run out of oplog in order for it to build that slave. And so what happens is, a common failure pattern is, hey, I've been running on my system for a year. This is awesome. Oh, I need to go compact. And now your system's huge. And before, you could rebuild your slave within the amount of time, the amount of window your oplog had. Now you can't. and so you run into trouble that way. So think about that too.
Yeah, I remember reading that with some features on MongoDB, like the aggregation framework,
Yep.
does not play well with sharding or in a sharded environment. Is that still the case?
Yes,
Going
so-
to 2.6?
That's true. So the question is, does the aggregation framework play nice with sharding? I think it is getting better. You know, just like anything, the initial release of the aggregation framework was very limited, and over time it's getting better. I think that's mostly true with all the framework, or with all the features. But that does bring up, I think, a really good point, which is not everything you do is going to be compatible with sharding. So cap collections can't exist in a sharded world. Time to live collections can. So I guess the point you bring up, which is a really good one, is that if you're using a particular feature in MongoDB, check it against its capability in sharding, right? So cap collection would not be a valid thing. You can't do it. In that case, you may actually, on each shard, you might create like cap collection A, B, C, D, E, F, G, and then in your app maybe assemble that. Or there could be other techniques. So,
I just a follow. Is it because of performance reasons, or is it just it's gonna give the wrong data, the wrong?
for a cap collection?
No, for aggregation framework.
I don't recall. I don't recall the exact issue with the aggregation framework and sharding, but you are correct. That has been an evolution over time. It was not 100% right away. Russell?
Can you give us a few points about backup
Yeah.
for sharded? At
Yeah,
scale?
this is a good topic. Some of the things I don't put on here because it's like a whole seminar in itself or a whole discussion in itself. Backups so you can imagine backups are tricky because a sharded system is never really at rest. If it's all working, the balance is running, things are moving, how do you get a concrete backup? So without going into all the details, I suppose, you have to actually, first of all, turn off the balancer, so that's not moving. And then you need to take a dump of each one of the members. And that's not going to be perfectly atomic, right? So when you back up a sharded cluster, you have to understand the expectation on restore time that it may not be in exactly perfect state as when you took the backup. Because you can't guarantee that shard A and shard B start at the same time, right? So that, maybe you do snapshots and you get close, but you're still not guaranteeing yourself unless you're on the exact same file system with the exact same atomic command. So it's tricky. My suggestion is, so a lot of folks, just as a side note, let's say you have a 5 terabyte database, and let's say it's sharded with like 50 shards. So it's a fairly big endeavor. Let's say that goes away, and you're like, I got to go to my backup. It might take you, even without consistency issues, 3 days to rebuild that thing. I don't know, would you still be in business? Like, does that matter? So I'd consider that. And that was true at my previous endeavors and previous businesses. I used to work at PayPal. If we had to restore from backup, we'd just say like, let's do into farming or something.
How big was it?
Multiple terabytes, huge. So each database, So my suggestion there is, so that's a long-winded way of saying, add more slaves. Okay, slaves are a good way to hedge. They're not a great way to hedge against human oopsies, right? So if you drop a collection or whatever, it's not going to help you there. Delayed slaves actually help that. And that's actually a feature that came from some of our early work at Shutterfly and we used to do an Oracle, it's an old school Oracle thing. So use those delayed slaves to protect against some developer oopsing or push, how many times have you push new code and it's like, oh, I just corrupted the entire user collection. And in MongoDB, not to be too long-winded about this, in MongoDB it's even trickier without a schema, right? Sometimes you can make decisions in application development context that have, like you start writing ints where there's supposed to be strings or whatever, you can make a mess quick. So, and you say, oh, I gotta go to backup. Well, you don't want to bring down the whole company just to do that. So delayed slaves is a great way to go. Turn it off, pull it out of the set, open it up, pick and choose what data you need and put that back in the database. It's manual. It's probably horrible customer experience, but it's not a company-ending event. That's a fantastic question.
If you use the aggregation pipeline and still having locking issues, do you still shard or do you do something different?
The question is, if you're using an aggregation framework and you're having locking issues, do you still shard? Boy, I don't know. That depends. I think that depends on your workload. It depends on how much you care about aggregation framework and how critical that is to your application. The standard playbook is to add more shards to get more lock scopes. But it depends on whether you can run n different aggregation frameworks and assemble them in your app, or your specific patterns. So I don't know there's an easy answer to that. I just play with it in dev and see how it works for you, I suppose. I know that's not a great answer.
What tools do you use for monitoring? So you use Graphite for historical data. Do you use MMS a lot?
MMS is interesting. MMS is not today very shard friendly, right? It's not going to give you shard by shard output. It's not going to give you a whole bunch of management tools and visibility against your sharded cluster. So MMS is not a great option today. I think in the future, I'm sure they're going to make it a lot better. Things like New Relic, things like server density, things like Scout, things like Graphite. We use Nagios.
If you don't know, MMS is Mongo's monitoring service, which is free.
Yeah.
So
Yep.
it's just mms.mongodb.org, I think.
Yeah, good plug.
Not that I work.
All right, any other questions?
So there's the config server you talked about?
Yeah.
So is there ever a time where you need to scale that system horizontally? And then is the network performance issue having to go to that machine every time?
Yeah, this is a fantastic question. So, question is, do you have to scale the config servers? Is there network issues ever? What was the other one? Those are the two?
Yeah.
Okay. So typically I drew 3 of them because typically you have 3. You do that because if you lose one, you've still got, it's redundancy and availability design. If you lose any one of them, then balancing stops and metadata can't propagate. It's a 2PC protocol that's used to communicate to the config servers. Typically, you do not need to scale those. The workload is very low, and it's not synchronous to the actual balancer activity, unless the balancer is like running. It doesn't need to fetch it for every query. I guess is what I'm saying. When a query comes in and hits the router, that hits a cache copy of the config server, and the config servers, the MongoS's check in with the config server at periodic intervals, where that interval is fairly small, to know what the changes are and where to route things. So no, not generally. Although if you had to, you can't shard them. You would have to grow them vertically, right? More memory or more disk. The network can be an issue. It's a good question. It's hard to say without knowing the payloads. Typically, you have to scale that because the data payloads are bigger, not because of the metadata traffic. So, but what I mean by data payload is you might start pushing so much data in and out of your database that you need better networking, but not necessarily because the overhead of the metadata operations of the balancer is causing that. Not in our experience, frankly. That's a good question.
Any tips and advice on sharding for applications like social media stuff, where you have these challenges where like the users have really skewed usage, and there's also sometimes like flashpoints where like I hate West say something stupid again, and like how do you sort of like handle those situations?
Right. So the question is like, how do you deal with things where you may have like a really busy user, or in our case, going back to PayPal, it used to be the UPS user. Do you remember? It was like this one company that had like dominated the usage, and so that's happened for a long time. Right? That's like a completely different type of system, and that pattern exists. So how do you hedge against it in MongoDB? I guess there's a couple tools, right? There's a couple things that you can do. I talked about max size. So let's say sharding is implemented. It's out. It's in production, and Kanye says something stupid, and shard A just blows up. It's a tough one to fix in that instant. But what you can do is like, Kanye says stupid stuff a lot, so I'm going to set max size down and hedge it. Or I'm going to take his chunks and I'm going to move them to another cluster or to another node in the cluster, and I'm going to turn off the balancer. So it depends, right? You could actually just say, look, I'm on a custom balancing. I don't want the balancer to run anymore. I'm in charge of my balancing because I know Kanye does these things, and I'm going to move his stuff over here. Right, so that would be one strategy. It's a pain in the butt, right? Like, 'cause that's now you're all in a manual mode and you've got chunks everywhere. But that would be one way. Another way would just be to hash on ID, and maybe it's not on his username, right? Maybe it's on his tweet ID or on the ID of the actual payload, and that is hashed. So then it would always be some random member of the node. So it depends on your design pattern, right? It depends a little bit. If you knew that was happening a lot, then you could have a design where the shard key, where the actual tweet's shard key made it balance across the cluster. So a couple different ways to do that. Russell.
Can you talk about the balance, the internals, which chunks selected?
I think that's a larger topic, and I may murder it. So, to be honest, so the question is like, how does it know what chunk to move? So, frankly, it goes out and it looks across the cluster to find out where it's not balanced. So, if, like I said, that one member had one chunk and the other two had 77, it would decide that it needs to go and fill that with chunks.
There is a delta. There is a table that they publish. There is a delta of chunks. It's kind of a lazy balancing.
Yep.
So you won't, like if it grows, you won't balance unless you have like 8 chunks difference, if I remember correctly.
Right, there are
So
three, that's right.
You won't go for like 2 chunks or 3 chunks.
Yes.
It depends on the size of the data.
Yep.
So it's
And it
kind
also depends on how many initial chunks you have, right? So there's some
Right, exactly.
conditions. So when you start adding data, it may not start balancing immediately because there's not enough chunks. So there's a bunch of conditions that I honestly don't know every one of them.
No, it's a little bit like
Yeah. You can look in the config server, there's a collection called chunks that shows all the chunks, and you literally can look through them and see all the ranges.
Sort of a follow-up to the config server scaling question.
Yep.
You might not know the answer to this. Why aren't config servers a replica set?
I wish they were. I wish they were. What's that?
They are sort of a replica.
Well, why aren't they a real replica set?
Because they're only one is primary and they all are synchronous. So it's a synchronous
two-phase commit
Yeah.
to make any changes, so.
Yeah, I can't talk to, so the point for everybody is why aren't they a proper replica set? Why is there a two-phase commit protocol used to talk to the config servers? Why is that the design? I don't know the answer. I don't know the philosophy behind that. I just know, what it is today. I think there has been, I've heard this, that's not the first time I've heard that.
I saw a ticket about it.
Yeah, it's not the first time I've heard that request or that discussion, but I don't know the answer.
So
Maybe Ben does.
The thought process behind it is that, obviously, if you have a change to your config, right, it needs to be basically guaranteed that transaction completes, right? And because it's so critical that if you don't have the metadata associated with where your chunks are within your cluster, you obviously have no visibility into the data on your cluster. So therefore, anytime there's a change, right, that change is not going to be committed until it's on all 3 copies of the config server. Right?
That's true, and so I think the idea there is that they believe that you have redundancy through 2PC,
Right.
but it wouldn't be a big deal to say, yeah, okay, that, and I want each one of these to be a replica set.
Right.
So I don't
You
know.
could just change it and make the right concern free.
Right.
Yeah.
Right?
Exactly.
But apparently they decided to
Yeah.
do it as a two-phase commit. because
Don't know, right.
it seemed more what.
Yep.
Last time I read, it was 1 config server for development and 3 for production. So there's nothing less, nothing else. So you can't go with like 5 config servers.
So yeah, and I can tell you, we run 3 config servers on all our production instances just because that's like the best practice, and that gives you sort of the best fault tolerance. Obviously, 1 would be insane. If you have 3 of them, there's no benefit really to having 5 of them or whatever. It won't even adhere to it. So,
It just gets slower every time.
Two-phase commit sucks for that condition.
anything else?
Which is why we designed our SQL databases in the first place, because the two-phase.
Yeah. Back to the future.
We probably wouldn't be sitting in this room.
Right. All right. Thank you, guys. Appreciate it.